Hey everyone, this is a video from my grade 10 class, Introduction to Applied and Pre-Calculus Math. This is our last video in chapter 6. Told you it'd be a short chapter, and this might be about the most algebra-ish thing we've done this year so far. It's a very key skill moving forward into for people who are going to move into the pre-calculus in grade 11. And it is the general form of the equation for a linear function. When I was your age in school, we used to call this standard form, and I was doing a little bit of research online, and there's some people who think there's a difference between standard and general form. There really isn't. It's very, very cosmetic. I'll talk about it a little later in a minute, but because I kind of grew up with the language of the word standard, sometimes I might slip into that vocabulary when I really should be calling it general, like your textbook does. Anyway, let's just recap real quick. What we know about straight lines algebraically is we've seen kind of two ways to look at them. There's the slope-intercept form, which we usually call y equals mx plus b. And then there's the point-slope form, which is y minus y1 equals m times x minus x1. And the difference between them is I use this one when I know the y-intercept and I know the slope. I use this one when I know the slope and really any point that could be on the line. It doesn't have to be the y-intercept. And the general form is usually written this way with capital letters. And what's special about this form is these other two forms we tend to leave things like the slope in fractional form, and if the y-intercept's a fraction we could leave it that way. But we actually try to avoid fractions in this form. So basically we would say that A, B, and C are elements of the set of integers. Some people use a z for that instead of I for integers. And we like to say that A is positive. So let's start by doing some examples here. Let me see if I can make this a little less blurry. I can't tell if that helped or not. But anyway, write this in the general form. Okay, so what I want is sometimes I call this the everybody out of the pool method, because everything here, the x term, the y term, and the constant, all have to end up on one side of the equation and nothing is on the other side of the equation. So I'm going to do that. This y is already here, so I'm going to minus 1/3 x from both sides. And I'm going to add 6 to both sides. Hopefully everybody has enough algebra background to realize that that would leave these two things canceled on the other side of the equation. I know some people like to think that they pick up these pieces and move them to the other side and they become their opposite, but that's not really how algebra works. Algebra works because it's perfectly fair and it doesn't change an equation any to add the same thing on both sides of the equal sign. So that's the way I'm always going to communicate it. All right, but this doesn't look like the rule I just set up there. I said that I kind of wanted these numbers, these coefficients, and this constant to be integers. Well, negative 1/3 is not an integer. Also, I kind of want the a number to be positive. So I'm going to multiply both sides of my equation by negative 3. And what that'll accomplish, negative 3 times negative 1/3, well, a negative times a negative is a positive, and 3 times a third is 1. Negative 3 times the negative 1 in front of y makes negative 3y. And negative 3 times 6 is negative 18. And that is the same equation that it was up here, but it's now in my general form. All right, why don't you give example 2 a try, see how it goes, pause the video and see if you can do the same thing that I did. Did you try it? Pause the video and give it a try. So how did it go? Did you realize that what you're going to have to do is add 1/4 x to both sides, minus 3 from both sides, but I'm going to rearrange it so I do the x, the y, and then the constant, so minus 3. Then I'm going to multiply the entire equation by 4, leaving me 1x plus 4y minus 12 equals 0. All right, so that's how I go from a slope y-intercept to a general form. Now let's try going from a point slope to a general form. This one takes a little more work because I've got this extra step of a bracket that I have to deal with. Well, you should have learned in grade 8 that you can get rid of a bracket in algebra by doing what's called the distributive property. Notice that I multiply both of the things inside the bracket by the -5 on the outside of the bracket. Then I'm going to, again, add 5x and 5 to both sides of the equation. So that's now 5x plus y. And if I add 5 to both sides, that's going to combine with the -2 to make +3. Okay, and for the last example on this page, I'm going to, well, let's see. I could distribute 3/2 through here, but why don't I, it doesn't really matter what order I do the distributive property or the step where I would multiply both sides of the equation. So I'm going to multiply both sides of the equation by 2 first. So in this, oops, and then I'm going to goof it up. Remember, every part of the equation is getting multiplied by 2. There we go. And if I multiply this thing by 2, I get that, right? Because 2 times 3/2 is just 3. If you need to see that, think about it this way. Okay, so now I'm going to do my distributive property. And now I'm going to move everything to one side. Now remember, I want the number in front of x to be positive. So you know what I'm going to do? I'm actually going to move these two to the other side by subtracting 2y and subtracting 4 from both sides of the equation. So on this side of the equation, those two things cancel. And on this side of the equation, I'm going to get 3x minus 2y, and then minusing 4 from what I already have as -12 makes -16. Now, this kind of looks backwards from that. You can flip the left and right sides of an equation. It really doesn't matter. So I can just rewrite it the way that it's supposed to look, like so. And there we go. There's the general form of that equation. And just to show you what this looks like, graphing calculators tend to need equations to look like the point slope form, or sorry, the slope Y-intercept form. The Desmos program doesn't. The Desmos can actually graph things in pretty much any way that I want them to. So let's take a look. That first example was y equals 1/3 x minus 6, right? There's the line for that. Let me zoom out a little. There we go. You can see it better. And once I was done with it in standard form, sorry, general form, see, I told you I'd do that, it looked like this. X minus 3y minus 18 equals 0. And as you can see, pink, black, or is that purple? Sorry, I'm not good with colors. Purple, black, same line exactly. Let's look at the next, let's look at the last one I did. The last one I did looked like this. It looked like y plus 2 equals 3/2 and x minus 4, which is, oops, that's supposed to be a plus, not an equals. There we go, which is that line there, right? It has a slope of, it goes up 3 for every 2 it moves over, up 3, 2 over, and it goes through the point, x is 4, 1, 2, 3, 4, and y is -2, right there, right? So this looks very, very different. But according to my algebra, this should be the same line. And look at that, it is. Blue, red, blue, red. So, as you can see, it's not a different line, it's just a different way to express it. For the most part, textbooks that want a final answer for a linear equation are going to want this version of it. So if you used the slope Y-intercept or the point slope formula to get your equation, chances are your textbook that you're working on is going to want you to change it to the general form. Okay, let's go back to the notes. Next page. Let's go backwards. What if I gave you an equation in general form and I asked you to graph it? Well, you have multiple strategies you can use here. I'll start with this one. 3x plus 2y minus 18 equals 0. Okay, so I'm going to graph that line. Well, let's see. I could use my algebra skills and rearrange this so that it looks like y equals mx plus b, because that's easy to graph. I know the y-intercept and I know the slope. Okay, so that's one way I could do it. The other thing I could do is I could make a little table of values. I kind of like the table of values one for this one. You know why? Check this out. And I think this is true in this next equation too, but it's true in this one as well. That notice that these coefficients are factors of this constant. Right? 3 goes into 18 6 times, 2 goes into 18 9 times. And what that means is, if I decide to make a table of values, and I look for the thing last unit that we called the x and y intercepts, or the horizontal and vertical intercepts, they will turn out to be whole integers. Watch and I'll show you what I mean. If x is 0, this would be 3 times 0, which is 0. So I would have 0 plus 2y equals negative 18. Got ahead of myself. Minus 18 is 0. Move the 18 to the other side by adding 18 to both sides of the equation. Divide both sides of the equation by 2. And like I said, we get a coordinate that is an integer. Let's do the same thing for the other intercept. What happens when y is 0? Where do I hit the x-axis? Well, I hit the x-axis where y is 0. So if y is 0, then this equation becomes 3x plus 2 times 0 minus 18 equals 0. So that becomes 3x minus 18 is 0. 3x equals 18. X equals 6. So graph the 2 points 0 over 9 up and 6 over 0 up. Take a ruler, connect the dots. And there we have it. Okay. The other way that I could have done this again is to rearrange this into y equals mx plus b form. And in fact, that's the way I'll do the next one. I'll do the next one in red so you can see the difference between the work of the two equations. So I'm going to take this equation and I'm going to rewrite it so it looks like that. So I'm going to isolate for y, which means I'm going to have to minus x and minus 9 from both sides of the equation. On the left side they'd cancel, and on the right side they just become negative x and negative 9. Then I'm going to have to divide both sides of the equation by 3. And remember that this is a 1, so that's negative 1/3 x, and negative 9 divided by 3 is negative 3. Okay, and now I'm ready to graph this thing. Remember, that's my y-intercept, and that's my slope. So put the y-intercept down first, negative 1, negative 2, negative 3. And then from that y-intercept, remember that that slope means go down 1 and over 1, 2, 3. Okay, and that's good enough. That's 2 points. But if you want more points, you can keep counting. Down 1 and over 1, 2, 3. I don't really need any more points than that, though. And there we have it. Okay. All right, example 6. Kind of more of this type of thing. Determine the x-intercept, the y-intercept, and one other point on this line. All right, so let's do that. Let's make ourselves a little table of values. So the x-intercept is, of course, where y equals 0. So plug in a 0 into the equation, and you get 5x minus 2 times 0, which is just minus 0. So I'm not going to bother minusing 0. So I have 5x plus 10 equals 0. Move the 10 to the other side. Divide both sides by 5. And the x-intercept is negative 2. Okay, let's find the y-intercept. The y-intercept is where x equals 0. So plug in a 0 for that x. 5 times x is nothing. So I have negative 2y plus 10 is equal to 0. I minus the 10 from both sides. Divide both sides by negative 2. And there's my y-intercept. My y-intercept is 5. So the point where x is 0, y is 5. And then it said, and I'm kind of out of room here, so maybe I might have to flip over and do this in the back or something, or use loose leaf, but one other point. Well, let's see. I can plug in pretty much anything I want. I could plug in what happens when x is 1, for example. But you know what would be nice would be to get something that, again, had whole integers so I don't have fractions. Now think about this. If I plug a number in for x, eventually it's going to get times by 5, join together with this 10, move to the other side, and then divided by -2. So if my last step is being divided by -2, and I'd like something that turns out to not be a decimal or a fraction, I got to make sure I have an even number. So why don't I just make, for example, how about I just take x and make it 4? That's an even number. So 5 times 4 is 20. 20 plus 10 is 30. Move the 30 to the other side of the equation. So I have minus 2y equals -30. And y would equal -15. So there we go. One other point could be the point 4, -15. Of course, I have an infinity of points to choose from. This has to be my x-intercept. This has to be my y-intercept. This, of course, could be any one of an infinity of points because it just says one other point. It doesn't say specifically where it is. I could have picked x to be 2. I could have picked x to be 6. I wouldn't pick x to be -2 or 0 because I already have those 2 points. I want different ones. It says one other point. But other than that, I'm really just limited by my imagination and my ability to calculate. Now let's move on to a kind of a word problem. You are selling snacks at one of FRC's basketball games. You sell hot dogs for $2 and sodas for $1. At the end of the night, you've made $100. Write an equation in general form that can be used to find out all the possibilities of hot dogs and sodas sold. Okay, so we're going to let x equal the number of hot dogs sold. And we're going to let y equal the number of sodas. So if I sell one hot dog, that'd be $2. If I sell 2 hot dogs, it'd be 4. 3 hot dogs would be 6. So 2 times x is the amount of money I'm making off of hot dogs. Sodas are $1, so plus 1 times y. And remember, you never have to write 1 as a coefficient. You know it's there. And then that would have to equal. I sold those 2 things, and they equaled $100. But remember that in general form, we want everything on one side of the equation and 0 on the other. So if I write this, I'm not quite done here. And this is where I was going to make the point that some textbooks call this standard form. And to turn it into general form, you, of course, have to get everybody out of the pool and move all constants, coefficients, and algebra stuff to one side and just leave 0 on the other. So that's my equation in general form. Will you have made $100 if you sold 35 hot dogs and 30 cans of soda? I don't know. Let's see. 2 times 35 plus 30 times 1. Is that a true statement? Well, let's see. 2 35s is 70. 70 plus 30 is 100. 100 minus 100 is 0. So the answer is yes. Will you have made $100 if you sold 28 hot dogs and 40 cans of soda? Well, like we saw up here, there's infinite points that can go along a line. So maybe after this solution being true, maybe this one's true too. Let's try it. 28 hot dogs. So replace the x with 28. 40 cans of soda. And I can already kind of tell that this one's not going to work out because 2 28s is 56. And 56 plus 40 is actually only 96. And 96 minus 100 is not 0. So no, you would be $4 short of $100. There we go. Sorry, I'm off the screen there. Okay, so that's the last sort of new notes section. What I want you to do now is what we stuck at the end of the book is some extra practice here on converting from one form to the other. So notice this is just like the examples we did. This is just like the first two examples where we go from slope-intercept to general. And then these two are just like examples 3 and 4 where we go from point slope to general. And there's just basically 2 pages of practice on that. The reason we've stuck these 2 pages here is because the textbook doesn't have a lot of practice on this incredibly important algebraic skill. So this is kind of part of the homework for this section. I will post an answer key for it once I've made one. I might even just videotape myself making the answer key so that if you get stuck and you can't see how to get the answer from the answer key, you could just watch the video. But if you check the answers, you've got the right answer, you don't have to watch that second video. Okay? So check the blog for the assignment from 6.6, and then starting Wednesday we'll review, and I think we'll be looking at doing a little Chapter 6 test on Thursday. Thanks for coming out, guys. Bye-bye.